get all of these abstractions in, right? What is a mouse? So position is its position on the right side of the scale, and what happened as a result, the scale shows a higher weight. Now you're getting into the nitty-gritties of it. Like the model understands maybe the semantics of what's going on, but maybe doesn't understand what the significance of it is, right? So you ask the model, do you think that is why people are laughing, right? And it says, I think so. And again, we're coming closer to the point where like you're able to get a very fluid interface with the model. Not just is the model able to get the semantics of a lot of complicated sections, but it's also able to interact with humans to get to that point, right? Maybe today we're not at a point where a model out there will look at this picture and just tell you that, hey, this is a meme, right? But you can get it there, which is extremely powerful for language models. Coming down to image generation, and I was talking about like how you're able to use prompts to like generate this, right? So think of it, a prompt as like Kermit the Frog in Star Wars, right? You can look at it and it follows the texture, the style, the movie, font, and the styles of a lot of these movies. So if you look at the one for Matrix, if you're already familiar with this character called Neo, he had these glasses that actually look a lot like that. But it was able to get these semantics from it, right? So it probably made that Kermit Neo because of all the semantic deep understanding that it got, both from like the visual part of it, mapping like text, and text to the meaning. This in general, like it's a very powerful tool. Maybe isn't all the way there yet today, but it's a step towards using language models as an interface for very, very powerful solutions. Another example is OCR. If you've used Google Photos or Apple Photos, you can actually search for keywords, and those keywords will give you very close to what you want, right? Even if that keyword doesn't exactly mean what you want. So for example, you can search elixir and it's giving you coffee and shops that have elixir on them, and it's doing a bunch of things over there. It's not just looking at the actual text content of these pictures, but their semantic meaning. And the same goes for that cat, which is a little more obvious, but it's just funny. Like I said, language models are becoming a very, very ubiquitous part of our life. Everything from Alexa to Google to Cortana to Bing to like any kind of search engine, any kind of like interaction with these AI assistants come with some augmentation of like language models, right? So before we go ahead, if you have any more questions about the inner workings of these models or like want to get deeper into that, I actually have used a lot of like slides from Jay. He's one of the folks at Cohere who works with us and has a very, very deep understanding of language models. He makes these lectures and these series out there that are really easy to follow and maybe something you want to look at after the slide. But before we go more into like what's complicated about language models and how you can use them, let's take a step back and talk more about Cohere, the company that I work for. We aim at making language models a part of every developer's toolkit. And that's a maybe very straightforward goal, but it's not always easy. Why is it not always easy? Well, for starters, till this paper that came out a couple of years ago, it wasn't straightforward to build these language models. The state of the art wasn't always that good, right? This paper basically led to this field of language models and general AI models that's called transformers, and that person right at the center of it, that's Aiden. He's our CEO and co-founder. He's actually one of the main contributors to this paper, and this paper ended up leading to transformers, which in turn ended up leading to like large language models becoming significantly more powerful, much easier to train, and really, really good quality. So NLP at Cohere, right? So in general, there are like different steps that get you to a very good model, and different steps that get you to a point where you can actually use this in production in solutions out there. Well, for the starter part, we have like text coming into this model, right? So imagine like you need large amounts of data, but then you also need large amounts of compute. And how do you train these models? These models are like billions and billions of parameters in scale. How do you train them? For starters, Cohere uses TPUs and large amounts of data and trains them. And TPUs are this specialized hardware for training that Google created. It's pretty powerful, but a TPU alone isn't enough to train. We need hundreds and hundreds of TPUs to actually train them. So to do this, we actually use JAX and Ray, two really powerful libraries that end up helping us train these models and get us to a point where we have a really good quality model. But when I mention quality, does everyone know what a good quality model would be, right? There's a metric about how good a model can be. There are different it's a budding field out there, but there are different ways you can evaluate these models. We have a team that actually focuses on evaluating these models based on different academic and internal benchmarks and tries to give the best quality model to the users out there. So every time we see a new model, we train a new model, we compare it and see if it's better than our previous one, and it's an iteration cycle, right? The best model of today isn't the best model of tomorrow. The next part is like, once you have all of this out there, these models that are trained, you then want to compare the quality of these and like look at not just like the domain specific results of these, but like every user might have a different space that they want to prioritize on. Some of these models are larger and that's why they have to be evaluated in a different manner. And some of these models bring in more challenges and complexity to it, which is where our team comes in. Once you've trained this model, once you actually want to productionize it, right, I'd argue this is the most exciting space for me. And I might have the bias because I work on a team that focuses on that, but our team actually ends up focusing on this area called model survey. It's a very, very challenging field for large language models, largely because of the fact that these models are massive and they're very computationally expensive. To get these models out there to users in a form that's usable, both in terms of latencies where users have like a seamless experience to it, and also in the form of reliability where you can scale up to cater to large amounts of traffic, it's not a trivial task, and that's one of the focuses of our team. We are hiring, so if you find this interesting, please do reach out to us and talk to us after. Even if you just don't want to hire, like don't want to come join us, if you want to just chat about this, have ideas or something, feel free to reach out to me after this. And then the last part, right? Like, okay, you've trained this model, you've deployed it out there, maybe you use some cloud providers to get you there for the last mile. You've scaled to traffic, you've done everything else. You still need like a very succinct interface for users, right? So we have a powerful SDK that actually allows you to interact with these models in different ways. And Nick will get to it a little more during the demo. But in general, like we have our SDKs that can be used for not just abstracting all of this, but then making it much cheaper to integrate your applications with language models and make them faster with like a couple of lines of code. So I'll start off talking about the different applications of Cohere in general. So in general, we have like 3 different endpoints or like functionalities that we have. But this is also not just in Cohere. In general, like these language models can be used for like 3 very, very basic things. For starters, like there's something called representation. You hear this word called embedding, feature vector, like different words being used out there, but effectively it's like the model's internal representation of the text that it sees. Think of it as what the model represents the content that you give it internally to be able to assign semantic meaning to it. Why is that something important? So if you look at general text, right? Like look at that text of how is it going, and that emoticon at the end. For a human, it's very easy to understand what that is, right? But prior to language models in general, not just large language models, a computer would look at that and be like, hey, that's ASCII or that's Unicode, right? And like that's the meaning to it. But it doesn't really understand what the semantic of it is. There's no meaning or like hard context assigned to any of this. So where does that change? Well, for starters, that's good enough for you to like check for passwords and ensure like something is safe and secure, right? But like it doesn't go well beyond just that. We need a way to find meaning and store that and ways to use that. That's basically embedding. Like I said, like it's not good for understanding similarities of 2 different texts. It's not good for like using it for summarization or classifying or like translating text to text, right? It's not useful. So what does this embedding basically mean and what does it get you? So think of it as like a language model that takes in like a bunch of text and then spits out this vector. This vector is like some high dimensionality vector that contains like floating point values, and that floating point value in some way or the other, believe me, is capturing the meaning of that. And you may say like, okay, it's just numbers, like where is the meaning, right? I'm not bullshitting you. It actually does have meaning, and I'll give you an example. If you look at the floating point representation, and I've reduced it down like just 3 numbers over here, but it actually is higher dimensionality, right? You look at 2 or 3 different texts, and you will see like one is closer to the other, and that's where this ability for it to capture context is in. These sentences, these paragraphs, right? They end up being mapped to a specific vector dimensionality, and that vector value is closer for things that are related. So how is it going is probably way similar to hi, how are you than it is to when did you open, right? and these language models put the space of these together. Another example of this would be like these sample text on the left, where are you open on the weekends, what are your hours, when do you close? They've been put together, right? They're very close in that state space. And that's questions about the schedule, the hours of operation. 4 and 5 are more like how much is the burger, what's the price of the meal, it's about the cost, about the menu, and so on. So like similar state space. And then the last part is, do you do delivery or is there takeout? Again, like similar state spaces, right? This is the power that language models give you in the form of embeddings. And this itself may not intuitively be very useful to you, right? But you can actually build a ton of really cool things just with alone this. Well, for starters, you can build classifiers, right? If you go back to the diagram out there, what's the classifier that you would build with these texts? Anybody want to throw out an answer? Alright, so it's basically like intent classifying, right? And intent is a big problem in language models in general. You look at a sentence and understand what's the motivation of the user, what are they trying to ask you, so you can direct them to the right thing. So if you had a chatbot, for example, you'd use intent over here to basically direct them to the right FAQ section. And that's just one example. So you can use these embeddings and build classifiers around them, where you like train like simple classification models with, instead of like the text as an input, use the embeddings as an input. And you have like maybe supervised learning to give you like a good classifier using maybe tens or hundreds of examples. And that's just one of the ways to build it, right? But we come to this problem of classification in general. Now you're using language models to do classification. You can do so much better. What does it unlock you apart from this like ability to train classifiers, right? It gives you the ability to do like things like action recognition, content moderation, which is again really important things, right? But how do you get this text classification out there? How do you like train it to do this classification apart from like with tons of examples, which you could have probably done with like a couple of years old models as well? You can actually, I'm gonna come back to this slide in a bit, but you can actually like fine tune the state space based on the input coming in. So for example, in this case of 5 or 6 examples, you see that the shipping, the catalog, the order being on time, items are sold out, all of these are like geared for semantic similarity because they're capturing meaning, but you might not be wanting to classify for that, right? So you can fine tune these models specifically for your use case, and when you do the state space changes, the model learns to put certain things closer, certain things further apart. And now it's easier for you to distinguish. So you can actually build classifiers on top of these, and they're far better. You don't necessarily even need to do a lot apart from that. And then the last part is something I find really exciting, called few shot. It's basically giving the model a couple of examples, not changing the status of the model. And by a couple of examples, you're able to build a fairly good classifier. You don't need tens or hundreds. You don't need a team annotating this data for you. You can actually just go and write a couple, and then Cohere's API allows you to specify that, and you go ahead, you have classifier on the fly. So great, you have classifiers with language models, and that's one thing you can do, but it doesn't end there. I mentioned a lot about semantics, right? Things that the language model captures about both the meaning, but in general, the strong language representation of these things. You can actually use your language models and their semantic meaning to do different things. One of them, for example, is ranking. So say you have like 5 or 10 results, and these results are ranked in some way. With some context, you can actually rank these in the right order for the user. And again, this is a complicated problem of its own. I'm not going to go too deeper into it. The other part is really exciting, which is dense retrieval. So you have a lot of content like this, right? How did it end up getting you the result that you wanted based on the search query that you had? It actually would look at embeddings of different documents and find the one that's most closely related to the embedding corresponding to the question that you have, right? And it would just use that similarity metric to order things and get you the right result that you need. So, for example, like you would see similarities questions, and then you could direct them to the right FAQ question in your page. You could use this in search. You can do so many things around this, right? Just using that similarity metric for semantics. But then we come to the most fascinating part about this. These language models are being used very, very commonly now for generative AI, which is a huge evolving section of AI, and it's a lot related to these language models in general. Text generation is basically where you give it a content, you give it like some prompt or some input text, and it just completes it. It basically goes on and adds in more content after that. In isolation of its own, you might not see the value of it, but I'd argue that this is probably one of the most powerful applications of language models. The ability for you to give it some context, some command, some information, and for it to do something very, very close to what human-like intelligence would be, which is like summarization of text, right? So you would give it like a long content of a document, and you'd say, hey, summarize this, and it would actually do a fairly good job of summarizing it. You can use strips and a lot of strategy to actually get that something to be better, but out of the box, this is like an entirely new technology the language models are giving you, summarization, right? Just by using generate. And the same thing could be like looked at in a different way. You could extract content out of documents. Like I gave you the example of Google search in the starting. It would actually highlight the respective section that you require, and that respective section was basically the extraction of the content. So the input going into a language model, right? It's just text, right? But a lot of folks and the industry in general refers to this as a prompt. It's prompting the model about what to generate next, right? That's the intuition behind it, and then the completion is what it ended up completing that as. It's a new field, and it's emerging as like a key way to get these models to do what you want. I'd argue that a good prompt equals to a good completion. So for example, if the summarization case, you gave it a lot of content and you just added those 2 words after that in summary, and it understands that, okay, in summary, I have to write some summarization of it. There's a link out there that actually talks a lot about prompt engineering and ways to get the best value out of these language models. If you do end up using generative AI, I recommend you to have a read of that. It's very fascinating, the difference of with and without prompt engineering. The next part I want to talk about is like reliable prompt generations, right? A lot of the times you can give an input to the model, and again, I talked about generative AI, it generates, right? A lot of the times you don't want the model to generate the same thing, but you want control over what the model generates. You can either change something that decides how vague the generation content is, or you could do tons of generations and find the one that's most relevant to you. An example of that would be to basically give an input and just generate 5 or 3 different things, right? All of them would be significantly different in terms of what they generate, but very related. For example, if you ask the model, your favorite fruit is, and then you ask it to do a completion, it wouldn't always say the same fruit, right? And here's like one of the crutches of generative AI, but also one of the things that's really powerful. This model will not deterministically give the same thing, but this model is capable of giving a lot more than just one. So you look at the outputs of this model, right? And maybe like you generate like five different things. How do you know which is better, right? Like how do you pick the right one out of this? Well, you could manually go and sift through it, but that doesn't scale well. You look at the best generation by looking at something called likelihood scores. When these models return results to you, there's like a likelihood score over here that kind of correlates to how likely is this sentence or phrase going to be something that you see naturally out there, right? Based on its understanding of the language. And something that's more likely to be out there would likely be what you're looking for. An example of that would be, on top of this birthday cake are dash candles. If it says 142, you're likely not going to see that out there. But if it says something like 14, it's more likely that you will see something out there. Again, very, very naive, but kind of an intuition amount likelihoods. There are other metrics out there for like finding the best kind of output for you. And I'd say like you can use the embeddings of your outputs and try to find the similarity of that with the question and go even further into that. I don't want to like, go very deep into that, but it's one of those ways where you can actually find out what you want. So think of it as like an open-ended area of research about trying to find out which are the best prompts, what ends up giving you the best results, and you can do so much with it, right? This is so meta. You're using a language model to kind of find out the embeddings for the output of a language model, and then that keeps on going further and further in, right? It's pretty fascinating. But like I said, language models are great. They're generative and they can give you different results. But our language models generally AI. For starters, if you've heard of Hitchhiker's Guide to the Galaxy, has anyone heard of this? Do I sound too old when I say this? Okay, there's a question in that movie that basically was asked to this computer that took 100 years to be built. This computer was supposed to be an AI, and the question asked to it was the question up there, which is, what is the answer to the ultimate question of life, the universe, and 42. Exactly. So we asked our language model at Cohere the same thing, hoping it would give us something a little more on those lines. And hey, like it remembers, right? It's probably looked at Hitchhiker's Guide to the Galaxy. That content is out there, and it knows the answers for it. Well, the model remembers, and it does that great, right? But again, you're not going to get the language, you're not going to get the language model to give you the answer to the life and everything in the universe. But what's the takeaway right here? Yes, the models remember, but these models aren't repositories of fast information. These models aren't general purpose AI, but they are capable of recalling things and understanding things. You should exercise caution by using these language models for facts, right? And Nick is going to talk a little bit about this maybe in his talk, his demo. But this is the concept of grounding language models. And again, not to steal any thunder away, but it basically is a way that you could use in the form of research or something else to look at results from the internet, give that as a prompt to your model, take your question that you asked, and get a generation out of it. So now your model doesn't just hallucinate or give you results, right? That it thinks is right or just generates random garbage. It's looking at actual content, actual sources on the internet, authenticity of the sources aside, but it actually gives you valuable results. And this is kind of sort of how Microsoft is using ChatGPT and other technologies to augment their search. It's a very fascinating space. All right, I know I ran around for quite a bit, but are there any questions? Yes.
Okay. Well, thanks a lot for the insightful talk. Two-part questions, really. Yes. One is that all the NLP models that you actually have at Cohere, do you guys train them from scratch, or did you actually use existing foundational models and fine-tune it?
To the best of my knowledge, all of these models have been trained from scratch.
Okay, they've been trained from scratch. And then can you speak to what are some of the challenges? Because when you're dealing with large language models, you talked about TPU clusters, you talk about distributed training. Can you speak a little about how do you actually train these models, and what are some of the challenges in training this model at a massive scale?
Yeah, so memory is a big challenge. So and again, I'm not an expert in model training. This is my understanding of it. But memory is a big challenge. These models require a vast amount of compute and vast amount of memory. How do you get it all this compute? A single device out there, there's no device that exists that can at scale very fast train these models, right? There are techniques that allow you to use CPU memory and offloading and a bunch of other techniques. But in general, the state of the art of how to train these models is to use vast number of resources like GPUs and TPUs. And TPUs is just something Cohere chooses to right now, but it uses JAX and in conjunction with Ray to basically train these models in a distributed fashion. And what that allows you to do is basically iterate through these models fast. Train these models with billions and billions of parameters on vast number of resources in a very cost efficient manner and get you your results. Does that answer? Anything else? Any other questions? Yes.
I'm curious, you said you're working on the model serving team.
Yes.
And I'm really curious, how do you optimize for the serving? I've been working with GPT-3 for quite some time, and it takes upwards of 5 seconds for completion to be produced because of the model size. So what are the strategies that you employ to get it faster?
Yes, so you're right, GPT-3 and other models are very large, very computationally expensive. Based on the GPU that you use, you can actually get a significant boost. If you're doing it on CPUs, obviously significantly slower, but at one point of time, you end up having it such that these models that you're serving in FP32 just take ridiculously large amounts of time. You try to quantize them. You try to get them to low precision, and that quantization needs to be done in the right way to get no accuracy drop in that. But once you do, FP16, for example, will give you a significant speed up, at least 2x, right? Based on just the difference. And then beyond that, there are different techniques out there. It may or may not be something that Cohere uses, but I've heard of techniques that actually do distillation of these models to reduce their size. There are other techniques out there that use better kernels, better optimizations of there. Not sure what frameworks and libraries you use, but there are like open source libraries out there that focus on optimizing these language models. NVIDIA has some, there are some out there by Hugging Face and PyTorch and so on, but a lot of these end up taking that 5 seconds down to like much lesser. The other challenge comes here for the fact that like those 5 seconds now without context may or may not be bad or okay, because these models take longer and longer depending on the output tokens requested by you. So if you ask for it to generate like 10 and you're taking 5 seconds, that's really bad. But if you're asking for it to generate like 2000, right, and it takes 5 seconds, it's not all that bad. So you want to try to find like the use case that you want to optimize it for. Use techniques like tensor parallelism, multiple like devices to share it, and then end up deploying these models. But that kind of is like a long answer to how we work.
Thank you.
All right. Yes. All right. A lot of questions. Let's start with someone. Yes.
Yeah, so on the training side, we do quantization of our trainings just to help in the inference side. And second, on the inference side, do you offer any actual on-prem services? Or is still, will you still have to do egress, go to encoder APIs?
For the first part, I'm not like very into the training side. I'm not sure if I could answer that the right way, so I'm going to refrain. But I guess it would make sense to do quantization of our training. Yeah. Yes.
So no, we don't do quantizer training, we do post-training quantization. For the second question, do we offer any on-prem solutions? We recently started offering our models on AWS SageMaker. It's not exactly on-prem because you would still be on AWS, but it will be your own managed instances of our models. We are planning to offer on-prem in the future, but not yet. Sorry, was that the question? On-prem? Yeah.
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 Thank you.
All right.
Actually, I have a follow-on question.
Yes.
So if I use my on-prem or even AWS SageMaker as a standalone air-gapped environment, do you use my own training, or does it federate and learn from other training too?
Cohere currently doesn't federate any of our training.
So it will all be my training on my data.
Well, yeah.
So we do offer our baseline models that have been trained on just data that we own at this point. Well, we don't own the data, but whatever we have scraped and collected. We do offer a fine-tuning solution on our platform so that you can actually take our baseline models and then optimize it for your use cases as well. The fine-tuning solution is not yet available on AWS SageMaker, but eventually we do intend to make it available as well. So eventually you will be able to fine-tune it on your own data sets, and that will be your own instance of the model.
Thank you. Yes.
I actually have two kind of disparate questions.
Yes.
The first one is, who owns the content that's created by your large language model? And the second is, I'm sure you've seen some of the failures of ChatGPT, like
Yes.
paper and stuff like that. Have you identified any classes of questions which are more likely to be answered incorrectly? And what strategies might you use to correct those problems?
Okay, I'm going to take the second part because that's the easier one to answer. Alright, so we have like an in-house way to detect something like toxicity of generations, both like on the input and output side. But in terms of like classifying the kind of things that would lead a language model to end up generating something that isn't something that we wanted to, that's a more harder problem. I wouldn't say that anyone out there, including Cohere, is completely corrected, largely because of the fact that like it's still something that's evolving today. As the models change, as they grow larger, and as we end up like using it for different things, exposing it to more people, we're learning more about how these models can actually be used. So while Cohere does have some safeguards, I wouldn't say that any of these safeguards out there by any companies are perfect. You'd see that example from ChatGPT itself, right? In the first part of the question, you asked me about
Who owns the content?
who owns the content. Now, I wouldn't be working on this, but as far as I understand, it's the user that owns the content. But I guess it's more of a question for the lawyer. Because it's kind of hard to understand, right? Like any model in general. Let's not talk about language models, right? If you talk about like content that went into the model, that content may or may not belong to users out there. An example of that would be the current ongoing lawsuit for Copilot, if you've heard about it. It basically talks about how like Copilot was trained on GitHub repositories, it may generate data, but that data might not necessarily be something that is given with an attributed copyright. So is it infringing a copyright by generating that data? So it's like a very open-ended question. There have not been strict policies in place for it, and like you probably will hear about it in a year or so when people start making more stricter policies about it, but I like the good question.
Well said, Hemant.
Yes.
So you said that at Cohere you train your own models, right, from scratch. I'm curious to know with this generative large language models, right, what test data set do you use, given also the randomness in output which they have? I'm curious to know how are you evaluating qualities of these models as you're iterating on your versions of these?
There are like a lot of public benchmarks out there, and some Cohere internally maintains as well. But if you look at academia, it's an active research topic. People publish data sets, and just like there's like ImageNet for like the ResNet and other challenges, there's like a methodology for evaluating these models formally. Maybe none of these are foolproof, but it gives you a strong understanding of whether the model is generating garbage, whether that model is generating good. Now, models aside, if you're just looking at the quality of the generation, one way to know it is basically doing something like, say, question answering. You give it data and you ask it to answer a question. Is it answering it correctly? So it's fairly easier to see that. There are like different metrics called row, meteor, etc. that actually looks at two different content, and instead of looking at character distance or like exact words, it basically will give you an evaluation of like how close whatever your answer is to that, right? Now, there's no perfect solution to it, and you probably want to run evaluations across multiple data sets, but there are enough papers and enough data sets out there to get you a fair confidence that your model actually generates better. That being said, I want to end by saying, ultimately humans are the best judge or to improve quality. Whether it's Cohere or whether it's anybody else out there that generates or has these models out there, if a human perceives the value to be better, if, for example, like it improves the click-through rate of a product, you probably know that it's better. So I wouldn't say LLM is better in general. It's better for a specific use case, right? Because there's no way for us to evaluate LLMs for every task out there.
Sure.
All right, any more questions? Yes. All right.
My question is, if you're building a machine learning model for a real world application, is it better to execute the model on the client versus on the server? What would you choose, and what are the benefits and drawbacks?
So executing on the client side may not necessarily always be possible for large language models per se. So maybe is that a question for general models then? Alright, so for general models, it makes sense to execute on the client side if these models give you the latency and have enough compute on the client side to get you the results. You may have to heavily quantize these models to like int or some precision like that to make them work, or you may use like different architectures that are actually significantly smaller. You get a fairly good performance. An example of that would be like we heard about the new Pixel phones that Google has. It actually has an offline mode over there where they have local models that do translation and other tasks. They're not as good, but they work. So it's more about like how high quality these models need to be, and that helps you decide whether you want them on the client side. There's another questions about privacy and other things like that, but I'm going to leave that out of the question. Yes.
Question here, sorry.
Yes.
Yeah, so I came across this recently, a paper called Instruct GPT where they rank the outcomes of different models, and they get users to label it with user outcome, and based on that the final model gets fine-tuned. So is there some kind of an ensemble learning in the products that you build?
So we do something very similar to what Instruct is. We have this model called Command out there, which we kind of ship out on nightly cadence. I wouldn't say it does everything that Instruct does, at least to the best of my knowledge, but it's similar to it in the sense of the fact that it is fine-tuned in a similar methodology. I'm not sure if you're asking it specifically for a specific domain, but yeah, we do something similar to that.
And thank you for taking the question. So since you're on the serving team, I want to dig a little deeper on the serving side. And I do agree with you for different use cases, there are different ways to modernize the serving. And for my particular question is for the large language model on your platform, and your team work on, what's the most effective way to optimize the serving?
So there are two parts to that, right? Are you optimizing for latency? Are you optimizing for throughput? Or are you optimizing for like just purely cost efficiency? If you want to optimize for cost efficiency, it probably makes sense to use the most cost efficient hardware out there. In your case, it could be like TPUs, for example, if you're capable of running that, or it could be T4s. I think that's the cheapest GPU on A100. But the question then comes to like, I think core question comes down to like what model size you want to serve. If it's a 52 billion or a 70 billion or 100 billion or like 175 billion parameter model, right? It's not probably going to be as cost effective as a much smaller model. The latency is going to be much higher. So there's that part of the question. The other part of the question comes from like quantizing it while retaining performance, parallelizing it as much as you can, and all of that kind of helps you optimize the model for like latency, not necessarily like generally would optimize it for throughput, right? So it's like a trade-off. There's no one size fits all, which is why like, it's an exciting problem to solve, and I'm guessing you appreciate it because being on a model serving team gives you the ability for you to like take your axe and like start chopping at all these problems. None of these problems are perfectly cracked. If you look at, for example, estimates of how much it costs to host ChatGPT, you'd see like it's in the hundreds of billions, right? And that's extremely expensive. Probably not something that can like scale up to the cheapness of like regular Google search. And so you have to understand the trade-off there and decide based on your product what the best cost model is. An example of that would be like Cohere offers like these models with like different model sizes, right? So for your use case, you might prefer like a much smaller model that doesn't maybe give you the quality of a larger model, but gives you much more throughput, much more latency. So, thank you.
Anyone else has any questions? Over there in the dining area, anybody?
Yes, one right there.
I didn't see you. Oh.
So I'm kind of new to this topic, but could you say a bit more about how the language model figures out embeddings?
Okay, so while looking at the content of the text that it sees, it's trying to predict the next word, right? And this is like an extremely like simplified version of it, right? So I might be abstracting away like some complexities, but when it's trying to predict the next word, there are some intermediate layers the model has, right? In those layers, it's learning some representation to be able to give you the result that it needs. That representation in some way is what that embedding is. So think of it as like in general, like not just for language models, but in general, any model in general has like multiple layers that it goes through, right? So there are multiple internal representations out there. At one point of time, you say like, okay, this is like the penultimate layer of the model, and maybe this has exactly the representation that I need. So that will give you the embedding that you need, all right?
So just to add to that, for embedding models, what you basically need is some examples that say that these two pieces of text are actually semantically similar, so that the model can learn about it. We do something called contrastive learning, where we try to identify articles, and if there are consecutive sentences, they're actually very likely to be talking about the same topic and likely to be semantically similar, versus if you take for sentences that are further away in the same article, or potentially two sentences from two different articles, then they're likely to have they're not likely to be as semantically similar. So we take that as a signal, and the model tries to basically then learn representations that tries to optimize for similar sentences together, and then farther away sentences farther away. So those are kind of the examples that we use to train the embedding models.
We also do offer like a fine-tune service where you can fine-tune for your custom data to get even better quality embeddings for your use case. But yes, thanks, Lee.
Anyone else?
Hi, thank you, great presentation. Quick question on the earlier part of what you were discussing around the quality and the amount of data you need to kind of even kick off the process of building a model. I've read a number of articles talking about different projects that don't ever make it because of the data quality problem. Teams get bogged down on trying to get the quality and the amount that you need. Question is, do you guys use internal resources to do some of the quality cleanup management, data labeling, annotation? Do you go through outsourcing? How do you guys manage that?
I'm not 100% sure.
So yeah, for some of the baseline models that we train, we actually use pretty much data that is crawled from the internet. We use Common Crawl. I think that's fairly standard. Many companies would do that. For some of the command style models or the instruct style models, we basically try to rely on high quality human curated data. We use both our internal resources in order to collect that data, but we also use external services that use human annotators to generate that high quality data. But obviously, like, the scale of those data sets are significantly smaller than the data set that we use, just from Common Crawl in terms of the number of tokens. So it's important to start with models that are trained on that wide corpus, and then they're basically fine-tuned on this high quality human annotated data sets for further quality improvement.
All right. Well, you can ask some tough questions.
Just wondering if the large language models are updated dynamically with like news, or do they have to go through a full retraining process when you get new data?
So if you're asking about like our baseline models, not the ones that you manually fine-tune yourself, our baseline models aren't updated on a daily basis. The cadence is more like on the months side, and I wouldn't say it's necessarily like the most up-to-date data, as in like you get like an October model out there with like October data, and I'd argue that it's not always that necessary. For like the vast majority of the tasks, the latest data this model gets is going to give you like minuscule improvement for like general purpose tasks. If you're talking about like a very specific task, for example, like question answering about like recent news and so on, I'd argue generally these models shouldn't be used in that format without augmenting with like grounded content, like true sources. For example, if you ask a language model like that was trained on 2020 data, the President of the United States is, it wouldn't say Biden, right? For the same example, like it would be outdated. So yes, you need to update these models regularly with new content to get the new evolving semantics of languages, but they aren't designed to give you the kind of factual information for like the recent news, right? So, yes.
What is the recommended paradigm? What is the recommended paradigm for retrieval augmentation for Cohere? Do you give them to the user with
So
LangChain?
it actually has like a demo that actually talks about it.
Okay.
So I'm gonna wait, not spoiling it for and maybe if you don't get to that demo, we can talk about it offline after that.
Any more questions? Hemant is feeling very generous with answering all the questions, so please.
Yeah, sure, I can take another.
Okay. Well, if you have more questions, you can obviously find them later after the talk. Maybe you can present the demo.
Yes. You want to use your laptop?
Yeah, I'll use my laptop. That's easy.
It's already loaded up here.